This is Fluency Module 3, Lesson 23, and we're going to be working a little bit more with factors throughout this. I want you to look at this array right here, and what is the width? And you should have said your width was 1. And what is the length of this array? Well, if we look across there, we can see that it is 8. So I want you to write a multiplication sentence that would match this array. And this is, again, as I always say, a place to pause the video if you need to write these things down. The multiplication sentence for this would be our width times our length, which would be 1 times 8. And if we happen to know that that is 8, if we were to count 1, 2, 3, 4, 5, 6, 7, 8, we've got it. So what if we had an array that is instead a 2 by 4 array? So if we were to draw that out, we would say, well, this is 2, this is 4. And what would the multiplication sentence be for that? Well, that would be 2 times 4 equals 8. So now we're going to list the factors of 8 that we have right here. Factors are the numbers you can multiply together to equal a given number. And in this case, we are trying to equal 8. So if we look, well, we've got 1 and 8, our factors. And we also have 2 and 4, because we can multiply those numbers together to equal 8. We're going to continue working on this. Skipped a page. We are going to work with factors of 12. So we're going to do the same thing. So let's think about 12. Well, we know, first off, that 1 times 12 is 12, right? So let's put those factors over here. We've got 1 and 12. How about 2? Can we multiply 2 times anything to equal 12? Well, we can. We can say 2 times 6 is equal to 12. So those come over here and are added to our factors. And we can also say that 3 times 4 is equal to 12. So those come over here. 4 times 3 is equal to 12, but we already have 4 and 3 over here. And 6 times 2 is equal to 12, but we've already got those listed as our factors. So we won't list them again. So our factors for 12 are 1, 12, 2, 6, 3, 4. Now, you could list them if you wanted. You could list them. It doesn't really matter what order you list them in. Sometimes people like to list them in numerical order, in which case we would say 1, 2, 3, 4, 6, and 12. Let's look at our factors for 16. We always know that 1 times the number itself is a factor, correct? So 1 times 16 will both be factors. So let's put the 1 here, let's put the 16 over here at the end. We know that it's divisible by 2, so we know that 2 is a factor because it ends in an even number. So 2 times 8 equals 16, so 2 and 8 would be over here. We know that 3 is not a factor, because we know that 3 times 5, is 15, and 3 times 6 is 18, so we know that 16 is not one of those. So we know 3 is not, but we do know that 4 is a factor because 4 times 4. We know 5 is not, 6 is not, 7 is not, and now we're back up to 8. So our factors of 16 are 1, 2, 4, 8, and 16. Factors of 18, you can start writing these down yourself. 1 times 18, so we've got 1, we've got 18. We know that 2 is a factor because of the even number on the end. 2 times 9, so we'll put in 2, we'll put in 9. We know that 3 is a factor. 3 times 6, put in 3, and we'll put in 6. And those are our factors because 4 is not a factor, 5, 6. We back up to 6 where we've already done all of our factors. So 1, 2, 3, 6, 9, 18 are factors of 18. Again, factors are numbers that can be multiplied together to equal another number. Practicing with it. So this one is a much bigger, All right, we are going to look at multiplying two factors. We're going to multiply 174 times 2. So when we do that, we're going to use this standard algorithm. So we're just going to write it on out. 4 ones times 2 ones, 8 ones. 7 tens times 2 is 14 tens. We'll carry that 1 over there. We'll put the 1 there. And 100 times 2 is 200 plus 1 is 300. So we know that 174 times 2 is 348. So right away, when we're asking what are 4 factors of 348 that we already know, well, we know 4 factors. We know that 1 times 348 is equal to 348. So those are 2 factors. And we know that 174 times 2 equals 348. So factors that we already know are 1, 2, 174, 348. This is a very big number. Do you think those are all the factors? No, they're not. But we do know some of them right away. All right, we're going to repeat that process. Now we're looking at 348. Keep in mind that 174 times 2 was equal to 348. So we're going to just do the standard algorithm here. This is a good place for you to pause your video and do it yourself. Times 2, 16, 4 times 2 is 8, plus 1 is 9, and 3 times 2 is 6. So 348 times 2 is 696. So let's think, what are 4 factors that we already know? Well, we know 348 times 1. We know 348 times 2. We know 696 times 1. And we can also probably figure out that 174 and 4 are those based on our previous experience. We are going to continue this process. So 696 times 2, we're going to do the standard algorithm. So let's look at that. 2 times 6 is 12. 2 times 9 is 18, and 1 is 19, and 2 times 6 is 12, plus 1 is 13. So 696 times 2 is 1,392. What are 4 factors of 1,392? Well, we know 1 and 1,392. And we know 2 and 696. So right away, we know 4 factors. Wow, we just keep going here, don't we? So now we'll look at 1,392 times 2. Again, pause your video, complete the work, and then come back. 2 times 2 is 4. 9 times 2, 18. 3 times 2 is 6, plus our 1 is 700s, and 1 times 2 is 2,000s. So 2,784. 4 factors would be 1, 2,784, and 2, 1,392, 392, and 2,784. All right, we're going to move into prime or composite numbers. So we need to look at 7, and you need to think, is it prime or is it composite? So composite means that the only factors are 1 and the number itself. So looking at 7, we can say we know that 1 times 7, 1 and 7 are factors, it's not divisible by 2 or 3 or 4 or 5 or 6. So we know that it is prime. And the factor pair, there's only one factor pair, that would be 1 and 7. All right, let's look at 12. So is 12 prime or composite? We know that 1 and 12 are factors. We also know, because it's an even number, that it for sure has more factors. So it is not prime. It is going to be composite, meaning there are more than the 2 factors. So we know 1 and 12. We know that 2 is a factor, and 2 times 6. And then we look at 3. Is 3 a factor of 12? Oh, yes, 3 is. 3 times 4. And we know there we have our factor pairs for 12. 1, 12, 3, 4, 2, 6. Probably write them a little different this next time. 15, prime or composite? Well, we know 1 and 15, so that would make it prime, but there happen to be more factors, right? Because it ends in 5, we know that 5 is also a factor. So we know that it's got to be composite, and we know that 1 and 15 are one of the pairs, and we know that 3 and 5 are also factors of 15. 17, prime or composite? Well, it doesn't end in a 2, so we know 2 does not go into it evenly. It doesn't end in a 5 or a 0, so we know that 5 is not a factor. So as we look at it, we know actually that it's probably prime, and it is prime. The only factors of 17 are 1 and 17. 2 is not a factor. 3, 4, 5, 6, 7, 8, and then we're to halfway, so we know that we're not. 21, prime or composite? I want you to think about it. I want you to write down prime or composite. And then I want you to think of what are the factor pairs. So start writing those down. 1 and 21 should have been written down. 2 is not a factor because it does not end in an even number, which would be 0, 2, 4, 6, 8. 3, well, we know 3 actually is a factor. 3 times 7. Is 4 a factor? No. 5 we know is not because it ends in a 1. 6 is not. 7 we've already got. So 8 is not. 9, 10, we're halfway there. So no, those are our only factor pairs there. All right, we've come to the end of this. We'll continue to work a lot more with prime numbers and composite numbers, as well as with factors.